And here we go. We are live. Are we live? I don't see a picture over there. Well, hopefully it'll straighten itself out. So if not, I'll get to do this again. Hello, welcome back to the channel. Welcome if you are new. We talk about global heating and allied things here, and it's been a little while since I was on. I've been busy and I really haven't had much to talk about. The problem hasn't gone away. I just have other things to think about, which is, yeah, maybe you do too. But anyway, my wife did a stream December 31st, and I think she did a good job. She talks about slightly different topics than I do, and that's fine. Her message was a good one, and I suggest you go, if you missed it, I suggest you go back and have a listen. Like I said, the format is different and the topic is different, but I think she still has valid things to share. So give her a listen. Today, well, you see, I'm all dressed up for the cold. According to my weather station, it's a frigid, icy, intolerable 58 degrees outside. I'm joking, of course. Yeah, it's cold for around here. But in other parts of the country right now, it's 58 degrees below freezing. So we're doing pretty good, frankly. We rescued some monarch butterflies. We found the caterpillars. I don't know who found them. Maybe I found the caterpillars. We found the caterpillars eating some of our milkweed. I don't like. It's not a weed. It's a plant, and milkweed, milk thistle, whatever it's called. And we found the caterpillars, and they're quite visible and showy. But it was going into winter. It was about 4 weeks ago, maybe 6 weeks ago. We were going into winter, and I said, "Look, we have to put them in the greenhouse. We have a nice little greenhouse, and she uses for her gardening, and so we hauled the plants. They're in pots, so we hauled the plants into the greenhouse, and they did really well. It's still been really cold. We don't heat the greenhouse, but the sun comes up and it warms it up inside, and they did really well. And then they pupated, which means the caterpillars, they formed their chrysalis, and that's how they turn into butterflies. So they pupated. We got, like, I don't know, 6 or 8 pupa, and from that we got butterflies. We got 1 butterfly so far. One of the ones that pupated soonest has turned into a butterfly, and beautiful animals. We let it out of the greenhouse to fly around. It's still visible in the backyard occasionally. They have a range. Once they emerge, they kind of stay in the neighborhood because they know instinctively that if they were living in an area, then there must be plants suitable for caterpillars. Otherwise, they wouldn't be there. So they kind of know to fly around looking for the milk plant, the milkweed, to lay their eggs on. And of course, looking for mates for that purpose. So we have 1 monarch butterfly flying around in our backyard. It's amazing. They're, of course, probably endangered. My guess is they go extinct sometime in the next 5-10 years. What can I say? We're doing what we can, and we have 1 of them flying around. The other 5 or 6, however many's left, I think 1 of them probably died. It's tough to be a caterpillar. The others will emerge at different times. Unfortunately, they probably won't all emerge at the same time. That's what you need, of course. They only last, I think, about 3 weeks, and it is cold. I see the butterfly sitting in places when it can't fly and trying to heat itself and waiting for the sun, and then it flies around and finds nectar and whatnot. Butterflies, right? So we'll see. Maybe we'll have 2 or 3 of them out at the same time, and then we will have had some kind of a success with the monarch butterfly. So it's tough. If you live in California, though, and you want to help the monarch butterflies, plant some milkweed. It's a fairly large family of plants, and there's several of them that the monarch butterfly caterpillars will feed on, and that the adults will lay eggs on. So find out which ones are available at your nursery and that grow in your area. They grow all over California wild. There's a milkweed that is really a weed. It's found along roadsides. It has a fairly large leaf. Uh, I was a kid when I was studying these things, and we had them growing across the street from our house. They have a really big gray leaf and a tiny little cluster of flowers at the end of each branch. And the plants themselves will get 3 feet high. They're not beautiful. They're not the kind of thing you deliberately plant in your garden because they're showy and pretty, but you might deliberately plant them if you want to support monarch butterfly populations. So that's my recommendation. We've been having a great time with our monarch butterflies. Our caterpillars are like children, and then they pupate and we're so proud, and then they emerge and we're thrilled. Parenting, right? So it's been fun, and I recommend it as a hobby. Like I said, we stumbled into them. They found us, and then we just took care of them. There is one caterpillar left outside on the plants that I took out of the greenhouse. One more caterpillar showed up. We don't even know from where. I hope there's enough leaves there left for him, it, to grow up and whatever. It's looking healthy, and we have some sunny weather, so if it can get some warmth, then maybe we'll have yet another chrysalis, this time outside. So, yay. Nature finds a way, as they say. So the topic today is not really about bugs, although I couldn't help but share that. The topic today is global heating, as usual. And I was just complaining about my 57 degrees, but in fact, like I said, they're having a tremendous storm east of us here in California. The Central States, the Plain States, Dixie Alley, they're getting a weather like they never see. Well, I mean, they get snow and they get cold and frost on the pumpkin and all that, but this weather is pretty much unhinged. Also, the same thing is happening in Europe. They're having unhinged weather. Oh, but it snows in Germany. Yeah, okay. But you can have crazy weather, even if you're accustomed to snow, whatever that means for you personally. You can still have snow and ice that is unnatural. That just happens. And you can say, well, we get this all the time. No, you don't. And they're saying, oh, yeah, we haven't had a storm like this in a decade or more. These days, if the weather people ever come out and say, well, we haven't had weather like this in a decade, you can automatically change that to a century, because the weather people are really scared of climate change. They are. They're terrified of it because their viewers, the uninformed people who don't really understand what's happening to them, don't want to hear it. It's scary. And so the weather people, the meteorologists, are constantly sandbagging. You can look that up if you want, but sandbagging is what you do when you just don't want to talk about something. I don't know where the term came from, but that's what we call it these days, is sandbagging. So the meteorologists are sandbagging, and if they say, oh, this is the worst storm in a decade, well, then actually probably it's the worst storm in 5 decades, and possibly a century, because that's just what they're doing. If they even mention that it's the worst in a decade, they're really counting on normalcy bias. That, yes, it'll be the worst in a decade. You shouldn't be out on the roads. You're going to die if you get caught in a snowbank. No one's going to find you for 3 days and you're going to die. But they can't say it's the worst ever. They can't say it's the worst in a century. But they will admit that it's the worst in a decade, and they hope that that's enough of a warning to their viewers to stay off the streets, stay home, make sure you have the medications you need, because you may be stuck inside for 3 or 5 days, maybe a week. And there are some places where the ice is so bad on the roads that the first responders, of course, police, highway patrol, sheriffs, all those guys, they're telling people at press conferences, we're not showing up. If you have a problem, we're not going to be there. And we don't know when we're going to be there. And of course, the ice is so bad that it's bringing down tree limbs. Those, of course, bring down the power lines and the communication lines. And even just the ice on the wires can be so heavy, because water's heavy. The ice can be so heavy after it accumulates that it can just pull the wires down. You don't even need a tree nearby. The wires will just come down because of the weight. So this is a pretty bad situation they're in right now. And of course, this is hitting the same area that was hit by Hurricane Helene last summer, western North Carolina in particular, where people are still living in tents. Maybe they're FEMA tents, but maybe they're not, right? Again, the roads are gone, so they can't get in there to help these people, and those people can't really get out except by helicopter. So whatever, they're staying on their land and they're living in tents. And this cold weather, I don't know what kind of tents they're in, but unless those tents are big and heated, these people are going to, how to say this, become unalived. It's over a huge region, like 1,500 miles long. There's a band that is below 10 degrees or even 15 degrees below zero. Now, that's Fahrenheit. Freezing is 32 degrees. 0 degrees Fahrenheit is 32 degrees below freezing. And this band of weather is now up to 17, I've seen 16 degrees below zero. So they are having, and this number is important. I want to make a point of this because this is the point of this discussion. They, in the middle of the country, okay, in the middle of Tennessee, Kansas, they are approximately 50 degrees below freezing. 50 degrees below freezing. That's cold. And now to get to my point, 50 degrees below freezing is, and 15 degrees below zero is Arctic cold. It's Arctic cold. It's not just cold because it's winter. And what does winter mean? What happens in the winter? The sun is further down on the horizon, right? In the summer, it's at our latitude, right? What are we here? We're at like 37, 38 degrees north, and that's about the same for the middle of the country. California, Northern California, is pretty much situated in the middle of the country as you go across. So at our latitude, we're temperate, and our temperatures, what is it? It's like I said, it's 57 degrees right now. That's about right for winter. And if you were to go east from here, it might get as cold as 40 degrees Fahrenheit, 35 degrees Fahrenheit. And right now it's like 50 degrees below freezing. That's cold. That's really cold. And again, you can have cold days in the winter because the sun is further down on the horizon, and in the summer it's straight overhead. But in the winter it's further down on the horizon because they're getting summer in the Southern Hemisphere, right? All this stuff to keep in mind. The sun is lower on the horizon. Because it's lower on the horizon, the air is slanting through more atmosphere. It's indirect. It is more of it is being bounced off, and also the days are shorter because the limb of the sun, the transit of the sun starts lower and it ends sooner. It starts later in the morning and it ends sooner in the evening. And your days are what we just had the shortest day, longest night. When was it? December 21st or so. The shortest day and the longest night. Now, from here on, the days start to get longer, but still dead of winter, right? Because it takes a long time for the sun to climb up enough in the sky during the day to give you very much sunlight. So right now, we are, getting not a lot of sun. It can be cold because there's not a lot of sun, but that's not the problem. Yes, that's winter. It happens every year. It's predictable. We've been having winters since whenever. Yeah, well, we've been having winters in North America since forever. That's orbital mechanics. Now, we didn't have snow since forever. If you think that winters in North America, so-called North America, I mean, we invented the name, right? If you think that winters in North America always had cold and frost and whatever, snow, well, you'd be wrong. Because there was a time when this planet, well, least of all North America, but certainly North America, this planet had no ice. There was no ice on this planet. That's hard to believe, right? Oh, it's always been ice. It must be. Well, that's normalcy bias. That's what you know. I'm not saying that to be mean. That's what you personally know. And we've had ice ages for 3 million years. And the Earth was cooling for 20 million years because of the CO2 being stripped out of the atmosphere by plants. But prior to this cooling era, this epic 5 million years of cooling, prior to that, there was no ice on this planet. There was no ice on Greenland. There was no ice in the Antarctic. There was no ice in the Arctic. There was no ice on hilltops, mountaintops. There was no ice. There was no glaciers in the Swiss Alps. There was no skiing. There was no nothing. It was all rain because the planet was too hot. The planet was too hot. That's true. There was no ice on this planet. And as we are heating the planet now, as we're putting the CO2 back in the atmosphere from where it was sequestered in the ground as fossil fuels, as we burn the fossil fuels and put the CO2 back in the atmosphere is warming. So eventually this planet will, again, have no ice. And that's just hard to imagine. That's crazy talk. No, it's not. And also, the temperature where I am here, at that point, the temperature will not drop below 80 degrees Fahrenheit. Ever. Day, night, winter, spring, fall, never. It'll never drop below 80 degrees. Day or night. In fact, the nighttime temperatures won't be much different than the daytime temperatures. And the winter temperatures won't be much different than the summer temperatures. Because it'll just be all hot. And you'll have winter, which means that the sun will be lower on the horizon, and the days will be short. There'll still be a shortest day and a longest night. That'll still happen. It'll still be around December 21st, if there's any of us here to to mark the date. And but there won't be winter as we know it. It just won't happen because it'll be too hot, and there won't be any ice. And if there's any temperature differential, it'll be quite small. And unfortunately, the daytime temperatures might get really super hot in the future, but we'll have to wait and see what happens with that. Global heating is a real thing, but it affects nighttime more than the daytime, and it affects the higher latitudes like the North Pole more than it affects the equator. So what happens is the temperature ranges start to collapse. They start coming closer together. So you'll still have really hot days, but you won't have cold nights. You'll still have really hot summers, but you won't have cold winters. Does that make any sense? The differential, the whole temperature range goes up, but the differential decreases. So the bottom goes up more than the top goes up. And they come closer together. Everything's increasing in heat, but the minimums, nighttime minimums, mountaintop minimums, North Pole and South Pole minimums, the minimums are approaching the maximums. The difference becomes less. That's the expectation. In fact, that's the observation. Nighttime temperatures are warming more under global heating than daytime temperatures. Northern latitude temperatures are increasing more under global heating than equatorial temperatures. Winter temperatures are warmer now than they used to be. And yet we're having 50 degrees below freezing in the Midwest. And why is that? So this is where it gets a little bit complicated. This is planetary physics, planetary dynamics. This is physics, okay? What's happening is that the North, I'm just talking about the Northern Hemisphere here. No one really lives in the Southern Hemisphere that we have to worry about. But everything I'm saying here would apply in the Southern Hemisphere. The Northern Hemisphere at the North Pole, it is warming a lot. We talk about the global average temperature. The average of the globe isn't very interesting. In fact, it's kind of a distraction. You really need to know what the temperature changes are everywhere. And there are maps that will show you that. I could probably pull one up now, but I'm not going to. There are maps that will show you that. And what they'll show you is that the anomaly, the change in temperature, the increase in temperature is more at the North Pole and above the Arctic Circle than it is further down. that means that the cold up there isn't as cold as it used to be, as I was just saying. The cold in the north is not as cold as it used to be. Now, it would still kill you. 50 years ago, if you'd gone to the North Pole, it would have been 70 to below zero. Instant death, right? You go outside, you don't have complete snow gear on and some sort of a way to get out of the weather real quick, you die. And of course, lots of polar explorers did exactly that. Also, the Northern Ocean, the North Pole is actually in an ocean. It's not land, but it's always been covered with ice. So you could go there. You could go there on a sled if you wanted to. You could fly there on an airplane and land on the ice if you could find a landing spot. But it's not land. You can land there, but you're not landing on land. You're landing on ice. Does that make sense? So now it's not nearly as much ice cover as it has been in the past. The old ice, the multi-year ice, is largely gone. There's new ice made every winter, so they have ice up there right now. But it's young ice, it's annual ice, and it will melt in the summer. Most of it will melt completely away. The ice is forming later in the year and disappearing sooner in the spring. So that's what's happening in the north. The north is warming a lot more than you would expect. And whereas it used to be 70 degrees below zero Fahrenheit most of the time in winter, and now it's 50 degrees below zero. Well, that's still really cold, but that's not as cold as it was. And eventually it'll be 40 degrees Fahrenheit in the winter, and then it'll be 30. And pretty soon it won't be below zero at all. Still really cold, right? 0 degrees Fahrenheit is 32 degrees below freezing, but it's not 70 degrees below zero. It's just zero. And that's what's happening in the north. It is warming faster than the south. Now, most of us live in the south. That's where the news people are. That's where the meteorologists are. That's where they go to school. That's where they look out their window and see what the weather is. That's where the weather stations are. They're in the southern part of the Northern Hemisphere. The U.S., Europe, the U.K., right? India, China, the southern part of Russia. That's where the people are. That's where the news is. That's where the newscasters are. So they talk about weather in their area. They don't talk about weather at the North Pole. They don't talk about weather up north of the Arctic Circle. They just don't do it. They don't talk about the weather in Alaska. The Alaskans probably do. I suspect they do. But the rest of us don't. You never hear about the weather in Alaska. Oh, you'll hear all about the weather in Florida and in Colorado and, Maine and the eastern seaboard and the Northwest. And you'll hear all about the weather. Every single day you hear about the weather. You never hear about the weather in Alaska. And you never hear about the problems with the ice being melted most of the year. You never hear about it. And the disasters this is causing for those people up there. Because they really depend on ice. So do most, if not all, of the animals up there depend on the predictable coming and going of the ice. It's a big part of their habitat. It's a big part of how they do things. It's the ice. Hard to imagine, but it's true. So it's not as cold up there as it used to be. And because it's not as cold up there as it used to be, the differential, again, between the temperate regions in the Northern Hemisphere, like where California is, and right across the bottom of the 48 states, the difference in temperature between the temperate regions and the Arctic regions, north of the Arctic Circle, has decreased. It's still really cold up there, but it's not so cold down here. And the cold up there isn't as cold as it used to be. And the difference between what it is now and what it used to be is really shocking. They're having a lot of warming up there. That is measured. We measure it with instruments. We measure it with satellites. You can see it anytime you want to if you know where to look. That it is anomalously warm up there. And as the differential between what's up, the temperature up there and the temperature down below, as the differential starts to decrease, then the amount of energy available, which is determined by the differences, the amount of energy available to create wind is decreased. The winds between the Arctic Circle and the lower parts of the Northern Hemisphere are what create what used to be called the jet stream. It's becoming less and less of a thing over time, and eventually it's going to vanish. But the jet stream, which was discovered in sort of the 50s when we started flying jets at high altitudes, passenger jets at high altitude, they discovered this atmospheric river. And after they charted it and mapped it, they realized it was just going around the North Pole from west to east, just going around the North Pole. They called it the jet stream. It's a stream. They could have called it the jet river if they wanted to, but they didn't. And of course, they discovered it using jets, so they call it the jet stream, because that's the only reason we knew it was up there, because we were flying passenger jets back and forth at high altitude that far north. And so we discovered the jet stream. And the magnitude of the jet stream, meaning how fast was this circular wind blowing, has varied over time. And one of the observations is it's slowing down. Why is it slowing down? Because the differential in temperature between the northern latitudes and the southern latitudes is decreasing. Okay? The northern latitudes are warming a lot, and the difference in temperature between the northern latitudes and the temperate latitudes is decreasing. They're still different, but the magnitude of the difference is decreasing. And as it decreases, the winds that are caused by the differential are also decreasing. The jet stream is slowing down. Not enough to slow down a lot. Eventually, it'll never stop, because part of it is caused by the rotation of the Earth. So there's always going to be something there. But right now, or at least in the past, the jet stream has been a strong enough circular wind right around the North Pole that it was able to trap Arctic air, frigid Arctic air masses in the north. And so when warm air moved north from the equator, trying to distribute heat all the way to the North Pole, it would hit this circular wind, and it would hit that circular, and it would head east. And the warm air from the equator couldn't get through. It would hit this, what we now call a ring fence. It acts like a fence. It's a fence of air. It's air that's so powerful and so consistent that it acts like a barrier. And as warm winds would attempt to make their way north to basically warm the North Pole and dissipate their energy. This is all energy, right? To dissipate their energy, they would hit this ring fence and then just get cut off, just sheared off and head east. So that's how things were for a long time. Those masses, those air masses, those freezing air masses, they wouldn't warm ever, because warm air could never get up there. The oceans are cold, and the oceans would actually freeze over. And so any heat in the ocean could not transfer to the atmosphere, because the oceans were frozen over solid most of the time, even in the summer. So there was no heat transfer to the North Pole. Basically none. The only heating that happened in the North Pole was in their summer. And even in the summer, the sun is never very high above the horizon. It's worse than our winter. Their summer gets less energy influx than our winter here in the lower latitudes. So there wasn't any heat input. The hot winds from the equator couldn't get through the ring fence. The oceans that were circulating and even got to the North Pole couldn't transfer heat because of the ice. It's just like a lid on a pot, right? Couldn't transfer the heat into the atmosphere. And the sun in the summer was so weak that it couldn't heat anything in the North Pole. So the North Pole was always cold. It just always was. Plus, there's so much ice up there, that what we call the albedo effect. The ice is reflective. So even in the summer, when there is sun, and it's eternal day, actually, the sun never sets. You think, oh, that's kind of nice. But the sun is low on the horizon, it's coming in at a steep angle, and then it hits the ice and just bounces off like a mirror. So with the ice coating and the low latitude, the low angle of the sun, and the ring fence and the ice layer, the ice cap, and the water couldn't heat the atmosphere, they just never got any heat. There was no heat input. So it just stayed cold. And the air masses at the North Pole, again, sticking to the Northern Hemisphere, the air masses at the North Pole were just freezing cold, like on Mars, right? 70, 80, 90 degrees below 0 Fahrenheit. Just super, super cold. And there was no moisture up there. It never rained. It hardly ever snowed. These are like deserts. They get half an inch a year, something like that, because it's just too cold. It's too cold to have evaporation, and you need evaporation to have moisture in the air to have rain or snow. It was just too cold. So they really didn't have any weather. Weather didn't never change. It was just cold all the time. And that was good for us down here in the temperate regions, because that cold could never really get away. It was trapped up there because of this ring fence caused by the polar jet stream. But as the difference in temperatures, the warming has happened up there, and as the difference in temperatures between the lower latitudes and the Arctic Circle, as the temperature difference decreases, the winds that spun up that jet stream began to slow. They became slower. I don't know what the percentage is, but guess what? It's enough so that the jet stream has begun to break up. The jet stream, the high altitude jet stream that would create the barrier to the exchange of air masses, has fallen apart. And this has been discussed a lot in climate studies and earth dynamic studies. One of the first people to point out a mechanism for why this had happened and why this was actually predictable was a woman, basically a mathematician, statistician named Jennifer Francis. And I don't know, 15, 20 years ago, she was looking at this and she was studying this and saying, and no one really knew what was happening with the jet stream. Why is it slowing down? Why is it doing this? Why is it doing that? And also, why was it getting these enormous loops in it? The jet stream, which used to be a fence, a straight fence, like you would lay a fence in your backyard. You'd lay it straight, right? He said, there's a fence. And then there's this side and there's that side, and the fence is straight. Well, the ring fence used to be reasonably straight. It was a circle, okay, but it was a straight circle. But then it started getting loops in it. And no one is up there to study this shit, okay? They don't know what's going on up there. All these climatologists and climate scientists, they're in Florida. They're in Colorado. I'm not even joking. And they didn't know what was going on up there. And we really didn't have a good satellite record. We really didn't have good instrumentation. For a long time, they just didn't know. If you wanted to know, you had to go up there. And who wants to go up there? It's terrible. It'll kill you. So they just didn't know. But because of the satellites, they began to notice that the jet stream, which used to be a circle, was beginning to get loops in it. And it was Jennifer Francis who came along and said, look, it's slowing down. It's slowing down. And just like any other stream, or if you prefer, river, when it slows down, will start to meander. Go look at the Mississippi River, especially where it starts to get closer and closer to the Gulf of Mexico, where it empties into the sea. It's got these enormous loops in the Mississippi River. Some of them even come back and almost touch it, touch themselves, and all these loops and oxbows and all this stuff. And whereas if you look at rivers in California, they tend not to do that. Our rivers are fast, and California, although it definitely has flat areas, the rivers are moving quick all the way to the delta, and our rivers tend to be more or less straight. Approximately so, because they're fast. And you go look at the Mississippi, and it's all twists and curlies, and it's like, how does it ever want to get to the sea? With all those bends and turns and oxbows. Well, of course, eventually it does, but it's slow. It's slow. And when rivers get slow, they begin to meander. And it was Jennifer Francis who pointed out, look, the jet stream is meandering. You've seen the meanders in it, and this is troubling. It's like, when did this start, and when is this going to stop? And it's not ever going to stop, because the jet stream is slowing down. And like, we call it a stream, we could call it a river, the jet river, and it's slowing down. And like the Mississippi River, made out of water, it is meandering. And she pointed this out, and people said, oh, that can't be right. Plus, you're just a mathematician. What do you know? Well, it turns out additional analysis plus the passage of time, when the meanders didn't go away, they began to notice, oh, yeah, that's right. She's right. That's exactly what's happening. And now we know the jet stream is slowing down. So right now, trying to bring all this around, okay? Right now, east of where I am, there is a massive ice storm. A massive ice storm. I am now going to go to my picture-in-picture, and we're going to be on the Max Velocity Weather Channel. He's on YouTube. He's a YouTube influencer. A young guy, college student studying meteorology, and but he does this wrong window. Wait, where is Max? Oh, here we go. Here's Max. Like I said, young guy, college student, and he does what he calls severe weather. So he'll do tornadoes, hurricanes, stuff like that. And I think it was even today, and maybe even in this broadcast. This is his today weather forecast. I'm sorry, I got him. I got him on a bad frame here. We'll get out of this in a second. He was saying that he's basically online now at YouTube, even though he's a college student. He's online at YouTube like every day, because whether it's winter, spring, summer, fall, there's always severe weather. And he does hurricanes and tornadoes and ice storms and storm surges, and he's really into the severe weather. He's not your daily meteorologist talking about the likely tomorrow temperatures. He's doing severe weather. Now, the U.S. is a big country, and there's lots of states, east and west, and north and south are they're a long way apart, so you can always get severe weather somewhere because the country is so big. But nevertheless, he's doing severe weather broadcasts pretty much every week, and some of them last 2 or 3 days. And when he does broadcasts, he's on YouTube talking about the weather. I mean, he does minute by minute, play by play. It's like he's watching a football game or a baseball game, right? Play by play. And he'll be online for 12 hours. People are even saying in the comments on this video, Max, you've been online for 12 hours, 3 days in a row. When do you sleep? When do you eat? When do you go to school? And so here's this guy. He's highly dedicated. He does a really good job. You should check him out. But he never talks about climate change. He never does. And there's been lots of times I've watched his stream and I waited for him to say it. Say it, Max. Say it. Say that this is because of a meander in the jet stream, and he won't say it. Because he's a meteorologist. And meteorologists are constantly sandbagging. Also, a lot of his people, because a lot of the severe weather is in the south and the southeast and the plain states, they're climate change deniers. And so neither Max nor Ryan Hall nor any of the others dare ever speak about the influence of global heating on all this weather. Even though Max does severe weather 2 or 3 times a week, and he does live streams 12 hours at a time to help warn people away from the tornadoes and help warn people about the hurricane track and help warn people about the ice storms. He'll be online for 12 hours. You don't have to, but he does. And he's trying to provide a service. He's trying to get people out of the way of these horrific weather events, severe weather events. They're severe. And if you think they're not, they are. They're severe. Here he's talking about the current ice storm that's tackling the lower 48, and I'm going to turn off my draw stick, and I'm going to go over here. Okay, so this is we're a little bit late in the game now. Let's see if we can find. Yeah, he's not really talking about what it was like yesterday, but this is pretty close. The earlier layout of this event was actually it's off the screen because it was over here in Kansas. So this ice storm extended all the way to here, 1,500 miles of ice and sleet and snow above that, and ice and sleet inside of it. There was half an inch of ice frozen to the roads. Half an inch of you say, half an inch. Half an inch will kill you. The roads are like glass. They're impossible. You'd have to have chains on or spiked tires, and even then it's almost impossible. 4-wheel drive, the whole thing, right? And then it's impossible. You have to dig through the ice, like an ice climber climbing a glacial face. You have to have spikes to get through the ice. And, of course, people weren't doing that. They don't have spiked tires. They don't have chains even. They're accustomed, because of where they live, right? They're accustomed to not having to deal with this. Now, a little bit later in this broadcast, let me put away my drawing tools. I'll come up to here. He starts talking about the jet stream, which what I've been talking about for the last, 20, 30 minutes. And I'm going to add something to his drawing, his map. These aren't his maps. That he did not. He will talk about this. He will talk about this, but only in the very limited context of one state or one region of the U.S. He won't talk about why this is here. He won't talk about what this is. This is the Arctic fence, and it's not in the Arctic. The place where this fence should be, holding back cold air, should be way up above here. Maybe even way off the page here. That's where the jet stream should be. Now, it does move. It moves, north in the summer and it comes south in the winter. But it's still a fence. What's happening in this case is that this meander, when this meander drops down, and I'll go ahead and set this to play because there's no audio. I'm not going to use his audio. Let's see. Okay, yeah. You see this? You see these bends? These are like bends. And he's noticing it. These are like bends in the Mississippi River. They're oxbows. These are the loops in the jet stream. And all this air right here used to be at the North Pole. Remember, 70 degrees below zero, up 100 degrees below freezing. This air here used to be at the North Pole. Now it's not, because the ring fence that held it up there like a shelf, has broken. And it's beginning to meander. And as these meanders come down, they don't just automatically warm to the temperatures you're expecting. What they're doing is it's a fence, and it. Think of it as an above-ground pool, right? An above-ground pool which has a wall that goes around and you fill it up with water. If that wall were to break, the water in the pool would spill out onto the yard. And that's what happens when this Arctic ring fence begins to meander and break, is it lets the cold air up there spill out. This is Arctic air. That's why in these areas, and he'll talk about it all across here, he'll talk about this. That's why the temperatures down here are 20 degrees below zero, 50 degrees below freezing, 20 degrees below zero. 20 degrees below zero is Arctic air. It's not supposed to be here. This is not weather. This is not winter weather. This is a calamity. Something has broken. And the thing that is broken is the Arctic ring fence. And it is meandering and it is being destroyed. And it's not able to provide the service it has provided as long as white people have lived in North America, which is to keep that cold Arctic air, 70 degrees below zero Fahrenheit, at the North Pole. Keep it up there and keep it cold. The fence prevents the cold air from coming down, but it also prevents the warm air from going up. They never mix. And as the Arctic ring fence has broken down, and you can see that here in this picture, multiple meanders. This is a chaotic collapse. This is a chaotic collapse of the Arctic ring fence. It's completely falling apart. Now he's going to talk about cold air coming down, cold air masses. He's not talking about the sun is low in the sky and the angle of the sun and the days are shorter and it's going to be colder because we have less solar input. He's drawing arrows showing you that cold air masses are coming down from the north and coming to reside in the lower 48. And this is a catastrophe. And what's causing this is global heating. That completely unintuitive. But as Jennifer Francis pointed out, the jet stream is slowing down because of the influence of global heating. Because the global heating is making the differentials between north and south a little less. And as the jet stream slows down, the ring fence that is created by the jet stream begins to break down, and it cannot hold back the cold air in the north, and it also cannot hold back the warm air intruding from the south. Now, what he's not going to show you here, and I'd have to go find a map before I could show you, is that at the same time, at exactly the same time that this cold air is coming south into the lower 48 and freezing us and giving us a terrible time, there's another mass of air that's ascending and going north. Because you can't bring an air mass from the north into the south without replacing it with something else. And so by necessity, since there's only one North Pole, then the air that's going to go up there to replace the air that's coming down is air from further south. And they just kind of trade places. No one's talking about that here. He's not talking about it. You'd have to be in Alaska to hear any news about the warm air mass that just showed up in Alaska and Canada and the Canadian archipelagos. Right? You'd have to be up there for anyone to talk about it. And is there anyone up there? Is there anyone in Alaska talking about the warm air coming to Alaska while this cold air is coming south? Of course not. They're all in denial. They're not going to talk about climate change or global heating or anything else. In fact, if it gets warm up there, they're going to be out, surfing and enjoying the beach in shorts and short sleeve shirts and sandals, and they're going to be out on the beach laughing, and of course the water's still freezing and the air is still cold, but they're going to make a big deal out of it, right? Hey, we're having summer in Alaska. That's what they're going to be saying on their news, summer in Alaska. Yoo-hoo, we love it. And so the two realities never connect in any one brain. It's certainly not Max and Ryan Hall, and probably not even you. No one understands what's happening to the Earth dynamic system. Yes, we're getting cold air coming down because the ring fence is broken. But that's only possible if warm air goes north. Now, this contributes to a further breakdown in the Earth dynamic system. Now there's warm air in the north. That's going to melt ice. That's going to change the habitat up there. That's going to change the weather. And the ocean doesn't freeze over like it used to, not as soon as it used to, and it doesn't melt as late as it used to. So now there's blue water up there. That blue water is warm because it's coming from the south, and the blue water is putting heat into the atmosphere, and the atmosphere is warmer than it should be. And instead of being 70 degrees below zero at the North Pole, it might only be 50 degrees below zero. Still pretty hot, cold, right? It's still really cold. It can still kill you. But that means in the future, it'll be minus 30 degrees below Fahrenheit. And then it'll be minus 10. And then it'll be 0. The coldest temperature will be 0 degrees Fahrenheit. Still 32 degrees below freezing. But guess what? It's not enough to freeze the ocean. Not enough to make ice. It's really cold. You wouldn't want to be up there. You'd want to have your best coat on, and you'd want to go home as soon as you could and sit in front of a fire. But nevertheless, it can't freeze ice. And remember, one of the things that's happening on this planet, as because of global heating, is this planet is going to become shortly, I believe, with immediate effect, ice-free for all practical purposes. And you'll find some ice on, in the Swiss Alps, and you'll find a glacier, and you'll find some ice up on the top of the Rockies, but most of the time of the year, you won't find any. Well, there'll be ice this winter. Yes, that's right. But it'll be later than it used to come, and it'll melt sooner. And where we're headed, and that's what really matters here. Not that you can find some little patch of ice and point to it and, say, yeah, I win the argument. What's happening is, the trend is, because of global heating, that this planet is becoming, it is on a trajectory that is going towards no ice. No ice. And these events where you get these enormous oxbows, okay, and I'll draw it again. These events where you're getting these enormous deviations in the jet stream, and there's even more than one here. There's actually two, and they're reinforcing each other, and they're like piling on at this point. The ring fence is so degraded that it's just pieces now, and the fact that this is happening to us here in the lower 48, and that the other side of the same coin is that it's hot up there, hotter than it should be. No one understands that. No one talks about it. The meteorologists are completely retarded on this entire topic. They don't understand it. They have no visual target for what's happening. I have seen other maps, and I don't think... let me see. I'll just skip through his weather forecast real quick. I think this is only about the ice storm. I don't think he ever talks about anomalous temperatures anywhere in here. I'd have to look up one of his other forecasts. Temperature anomalies. There's nothing in here about temperature anomalies, so I'll just leave it for now. I've had that discussion elsewhere. But sometimes when he's doing temperature anomalies, he'll show that there's a cold air mass coming down, but he'll completely ignore. I'm not being mean to Max. I'm just saying what he does. He will point out that down here, I'm trying to get some colors here, because this is what the maps look like. That down here, there will be a cold air mass, and they're usually in blue. They try and color code them correctly. He'll show you there's a cold air mass that came down from up north. He'll draw the arrow. Cold air mass came from the Arctic. He'll say all that. But what he won't tell you, and sometimes the maps even show it, what he won't tell you is that up here, and it's usually like over here, there's a warm air mass. He won't tell you this. He won't say that it's on the map. It's visible. It's anomalously hot. But he won't ever point this out. He'll never talk about this, even though it's on the map. One time, and I watch him a lot because he does a really good job. And I'm interested in what's happening. And he does the good job for the information I want. He has data that is useful to me. And he discusses it as data in a way that's useful to me. But he doesn't discuss all of it. And I'm pointing out to you the part he does not discuss. It's there. It's visible. He just doesn't mention it. And he won't mention this hot air mass up here. And this is in the Canadian boreal forest. One time he did. One time on this map, when he was down here talking about this cold, one time there was a band of hot that went across the entire picture. The whole thing was just one big blob of heat off the top of the map. And I think the way he brought it up, he was ignoring it at first. And then he said, oh, and this up here in Canada, this is anomalously hot. And then, but I think he just kind of startled himself. And this was about 3 months ago. So we're going into fall, and we're already getting cold air masses coming down because this shit show starts early, okay? We're already getting cold air masses coming down, and he was looking at the temperature gradients, and he was ignoring this hot band at the top of the picture. Just ignoring it. And I was saying, Max, what about this? And he just kind of startled. He was talking about this and that in Kansas and Missouri and blah, 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 and maybe Florida. And he just kind of did a double take. Oh, yes. And to the north, there's this hot air mass. And he was like, you could kind of see the gears turning. But because he's not a climate scientist, he's just a meteorologist. I'm being mean, right? I'm not trying to be mean. I'm saying that there's a limit here. It's a cognitive bias. And because he's a meteorologist and he's in school to learn meteorology, daily weather, weekly projections, he couldn't mentally cope with what was clearly happening, which is that the north is anomalously hot. There's something going on up there. And he kind of even shook his head and wait, should I say something? You could kind of see the gears turning. And he said, yes, and up here you see it's anomalously hot. But that was like the one sentence. That's all he could do. And then he moved on. And I've never seen him mention it again. Because he can't. Because the people who watch his program all live down here. They all live down here. And these people are all in climate denial. And if you ever point out to them that there's any part of the planet that's getting anomalously hot and it's not summertime, they'll give you a lot of trouble. And I've seen some of the comments. when I've seen the comments, I've made comments, and I've made comments like, okay, there is some climate change going on here. And they will respond to me, and they will also respond to him. If he even steps a toe in climate discussions, he gets brickbats. Okay, he gets brickbats. And they'll tell him, keep politics out of weather. Stick to the weather. You're good at the weather. Don't get involved in politics. And it's like, this is not political, people. This is physics. This is Earth dynamics. The Earth is a physical system, and it obeys the laws of physics. And it doesn't do what you want. And it doesn't even do what it used to do. You have no control. And if there is a band of heat that extends all the way to the North Pole, and it's barely visible on the map because the map is focusing on the lower 48 and part of Canada. But if there is a band of heat, anomalous heat, and it can still be cold, but it's anomalous hot. It's hotter than it should be, and that's all we care about. We don't care about the absolute temperature. All we care about is that it's getting hot. That's what global heating does. Global heating doesn't mean every place on the planet is a balmy 80 degrees. What it means is that every place on the planet is getting warmer. And if the North is getting warmer, if the Arctic Circle is getting warmer, then it's getting warmer. It doesn't mean that it's above freezing or it's going to be comfortable. It's getting warmer. And that's why we call it global heating, okay? Words matter. Words matter. Physics matters. But he can't mention this. If you're ever watching one of his things and he brings up the temperature anomaly map and he's trying to get you to focus down here about how cold it's going to be, but there's this band of red all across the top of the picture, he won't say a word. I'm saying that word. I don't have the picture here to prove my point, but maybe sometime when he has the right image up, I'll just do a screen capture and I'll bring it up here and we'll do this again. And he won't mention it. And anytime he even stutters, like, and this worm is in the northern Canada and this is anomalously warm, he can't say it. Now, why is this a big deal? This is a big deal because these cold air masses that are coming into these southern states are not supposed to be here. This cold system that came through and basically it just beat up these central states, central vertically, all right? Just beat these places up. This cold event is anomalous. This isn't supposed to be happening. And it's happening because of an Arctic air mass that escaped through the supposed ring fence, which isn't a fence anymore. And this is going to happen all the time. Every winter, this is going to happen. Right now, it's happening in Europe. They're having exactly the same experience we are. We don't hear about it because our meteorologists are not climatologists. If someone was a climatologist, they would point out not only is this happening in North America, it's happening in Northern Europe because it's the Earth dynamic system and the planet is round and everything that happens in the West happens in the East because reality. Now, Max won't do that. And Ryan Hall won't do that. No meteorologist will do that because they're going to focus on temperatures and rainfall totals and how cold they're going to get at night, and they're going to talk about the weather. Meanwhile, what's happening to them and happening to us is global heating. Global heating is happening. That's what's happening. And these weather events aren't weather. They're not weather. This is the Earth dynamic system breaking down. I mean, if you were in your car and you were going down the street and you got a flat tire and you pulled off the road, okay, you pulled off the road. That's one type of thing. If you're going down the street and you hit a tree, you're also on the side of the road, but it's not the same. Your journey has been interrupted and you're now on the side of the road, but in one case you have a flat tire and you're scratching your head wondering what you're going to do about this, and in the other situation, you're dead. This is not weather. This is not the same as weather in the winter. This is not winter weather. This is not caused by the longest night and the shortest day. This is not caused by the sun being low in the sky at noon. This is not caused by any wintry thing. This is not weather. This is a breakdown of the Earth dynamic system. And it's made visible if you know how to interpret this. This is the jet stream. This is a jet stream, and it's not supposed to look like that. In fact, probably, you wouldn't even see this at all this far south. You wouldn't see this at all. Least of all, 2 of them. Yes, they're getting ice storms. Yes, it's 20 degrees below 0 Fahrenheit. Yes, the ice is half an inch thick on the roads. And they're not ready for it. And they've never seen this. If they lived in Alaska or northern Canada, well, then this would be like, yeah, that's winter. But this is not winter for us. And this is not winter weather. It's happening in the winter, and the meteorologists will call it weather, and they'll call it even severe weather. But it's not weather. It's a train wreck. There's nothing normal about this. Now, it's going to become normal because people have a normalcy bias. And they'll say, well, it was just like this last year. Yeah, but it wasn't like this 20 years ago. Oh, well, things change. Yeah, you're having a train wreck here, all right? You're having a train wreck. The Earth dynamic system has derailed. And you're in the middle of a train wreck. And don't tell me that the trains come through your town and have train wrecks every day. Don't tell me this is normal. This is not normal. This is a train wreck. And if trains that came through your community really did derail every single day, and that was normal, and this is normal too, then you'd have a big problem. There's something wrong with your rails. There's something wrong with your trains. And there's something wrong with this picture. This is a train wreck, is what this is. And it's not going away. It only gets worse. The North can only get warmer. It will never get colder. It will never be as cold as it was today. It will never be as cold as it was this year. 2024 will go down in the books as the hottest year in the instrument record, which goes back variously either 40 years for satellites or 150 years for normal measurements, normal meteorology. 2024 will be the hottest year on record, and 2023 was the hottest year on record up to that point. And I'll make a prediction about 2025. 2025 will be the hottest year globally on record, and 2026 will be the hottest year on record for the globe, for the planet. Now, maybe not for your little podunk town in Missouri or your little country in the Southeast Asia or your little hamlet on the northwest coast of California, but the globe as a whole is heating. This never stops. This situation right now, this train wreck that's happening right now in winter in the Northern Hemisphere gets worse. It does not get better. Now, one thing that happens that will mean that eventually this doesn't matter anymore is that the North is getting warmer. And when you pull down an air mass from the north, which used to be 70 degrees below 0, now it's 50 degrees below 0, and now it's 30 degrees below 0. And slowly the North is warming, slowly but inexorably. And eventually the North will warm enough that it has no ice. Patches here and there, but essentially none. From satellites, you might not even be able to find it. You have to be on the ground looking around with magnifying glass. Eventually, if you're on the ground, you find the ice. But for every practical purpose, there won't be any. And more importantly and critically, there won't be any sea ice. And at some point, the air up there isn't cold anymore. Without the ice and without the ring fence caused by the polar jet stream, the air masses just mix constantly all year long. And eventually, there's no cold up there. The cold is gone. Where did it go? Well, some of it slipped south and just mixed in with the atmosphere. Some of it was replaced by warm air coming north. And so the cold just disappeared. It's just gone. It's just not cold anymore. And that's good because when the cold air comes down and it mixes with the lower latitude air and that cools us off, right? It's not as hot as it might otherwise be. And so we'll have an air conditioning effect from the cold air up north no longer being trapped there and descending into the southern parts of the Northern Hemisphere and cooling things as it goes. That's a thing, right? That's a benefit, but it's it's not net of net. It's really not what we wanted. We wanted the Earth dynamic system. We did not want global heating. We do not want atmospheric, Northern Hemisphere warming. We don't want a lack of sea ice. We don't want Greenland to melt. We don't want these things. And if you're going to be selfish about it and you're saying, wow, my winters are so much warmer than they used to be. Even with the Arctic masses coming down, it's still, shirt sleeve weather. I remember back in 2024, it was minus 20 degrees Fahrenheit here. But now, the coldest it ever gets in the lower 48 is, 0 degrees Fahrenheit, maybe even not even 20 degrees Fahrenheit, which is still 12 degrees below freezing. But hey, it's not minus 20. 20 degrees below zero. It's only 10 degrees below freezing. And so you'll say, hey, net of net, this is pretty good. And maybe your winters will get better, but your summers will be unbearable because of global heating. The effect of the North being a place where heat could go to die, essentially, will be gone. The North was a place where heat could go to melt ice, and there isn't any. And instead, it just warms the air and warms the water and contributes to global heating. The warm air from the south goes up there, warms things up, and that's it. And later on in the winter, when it comes back down south, behind these loops and meanders, it's not cold air anymore. And winters will get warm. And the rivers that used to freeze won't freeze. And the Great Lakes that used to freeze won't freeze. These won't, because it's too warm. It's already a problem, by the way. The other thing they're having right now is, so here's the Great Lakes. There's a lake here, and there's a lake here, another one up here. These are the Great Lakes. And over here in New York, in this band right here, they get what's called lake effect snow. And what happens is that the winds in North America blow from north to south at an angle. And so when the cold air, of course it's cold air and it's dry. When the cold air comes down in this direction and blows over the Great Lakes, if they are frozen, it just stays cold air and dry. But if the Great Lakes are not frozen and they're blue water, then this cold air picks up moisture from the surface of the water, which is warm. That's why it's not frozen over. It's warm. And therefore it picks up that moisture, and because it's cold air, it turns that moisture into snow. And over here, you'll get what's called lake effect snow. And they're getting 6 feet of snow right now. The same air mass that came down into here and froze these people, okay, it came down into here and gave these people lake effect snow. It's the same air mass, but it's passing over the Great Lakes. They get huge accumulations of snow, 6 feet, 12 feet from the Great Lakes. In the winter, it's not supposed to be a problem because the Great Lakes are supposed to be frozen solid. There is no liquid water to contribute moisture to the atmosphere. But because they're not freezing anymore, or they're freezing later in the year, or they're not freezing solid, when these cold air masses come down, they pick up moisture from the blue water. And then they deposit that moisture some 100 miles later as snow. And there's a ton of it. Over here in New York and New England in general, they're getting lake effect snow. And it's not a big part of the country, and it's not even an important part of the country. Who cares about upstate New York? Who cares about Buffalo, right? But they care and they notice. And 6 feet of snow for them is snowpocalypse, right? That's a big deal. So, but it's not because of the cold air mass coming down, although that's necessary. It's because the Great Lakes didn't freeze. And what was I saying? You're not going to have ice on this planet. And it's going to start in places like this. So, we're already seeing the effects, like around here, of lake effect snow because the lakes are not freezing because they can't. And eventually, there will be no ice on the Great Lakes in the winter. None. And lake effect snow, which is like a paradox now, right? Even the Great Lakes aren't frozen. How come we're getting 12 feet of snow over here to the east of the Great Lakes? It's because the cold air is picking up the moisture, freezing it immediately and dropping it some 50 or 100 miles later as snow. And if these were frozen over, if these Great Lakes were frozen over, you couldn't have lake effect snow over here. You couldn't, because there's no moisture. Does this make sense? Does this make any sense? This is the Earth dynamic system coming completely unhinged. The wheels are falling off. And for now, we are in really a bad situation. There is still enough cold up north that can be dragged south by these meanders in the jet stream to cause real problems, big problems, serious life-threatening problems. These states that are in the way of this, get rid of my tool here. These states that are in the way of this event have declared emergencies. That's going to cost money. The roads, there's a road that goes right down the middle of this called Interstate 70. It's closed. 1,500 miles of Interstate 70 servicing how many cities, how many industrial sectors is iced over. Half an inch of ice. You get on Interstate 70, you're gonna end up in a ditch. You're going to ruin your car. You're going to have to wait 24 hours to get towed out. And if things don't work out well for you, you might just die. You might freeze to death. And believe me, they're out there right now pulling people out of the ditches and getting them on their way because they're worried about them freezing to death. And why are these people out here on Interstate 70? They've got half an inch of ice on it. What are you doing? You don't have spiked tires. You don't even have chains on. What are you doing out here? Well, I had to get to work, and I had to go to a wedding, and I had to go, whatever. And now you're in a ditch. And if someone doesn't come and tow you out, you're going to die. And these states have declared states of emergency. So is this weather now? I mean, there are nervous Nellies. They shouldn't be doing that. No, it's a problem. They're declaring states of emergency. They need extra money. They need help. They need mutual aid. They need fire engines and tow trucks and ambulances, and they need lots of help. They need people to show up and bail them out because they're in an emergency state. So that's what's happening. When does this stop? This stops when the north is as warm as the south. When the North Pole is as warm as these states, then these states won't have to worry about this event. And at that point, the Earth dynamic system has completely failed. And there's no ice anywhere on the planet, more or less. Essentially, for all practical purposes, there's no ice anywhere left. Well, that's where we're headed. So I wanted to talk about this today because, for one thing, it's on people's minds right now. It's a big event. I shouldn't leave here without mentioning. Let me get my drawing tool. This is an interesting little thing right here. Did you notice this? This is rain line, rain and tornadoes. This rain line came from the Gulf of Mexico. This is actually a little bit of a comma-shaped circulatory pattern. There's a little bit of a spin to this right in here. And it's dragging this moisture up from the Gulf of Mexico. And that moisture is what's colliding with this cold air mass and creating all of this kerfuffle. The Gulf of Mexico is record warm of late. Like all the oceans are record hot. The oceans in 2023 went off the charts. The global oceans went off the charts. And as of the last data, I don't think they've come back into line with expectations. The global oceans are now off the charts. So this water down here in the Gulf of Mexico, which is barely visible on this chart, this water down here is really hot. And if there's a little bit of a breeze coming off of this, heading north, as often is the case. Remember, our winds tend to blow from west to east, which is left to right on this image. And the ones that come down from the north come down from basically the northwest, and the ones that come in from the Gulf are coming in from the southwest. So, and they collide. They collide in this band right here, and this is Tornado Alley. And this happens all year round, pretty much. All year round, these two types of masses are colliding. But this time, the mass that came down was super cold. And the air mass that went up was super wet and moist and warm. And they collided. And that created this line of annihilation, where they're basically at war. These two air masses are at war. And all the snow and all the ice and all the everything is coming from the Gulf of Mexico. It doesn't come from the north. The only thing that comes from the north is cold. Cold air can't contain any moisture. The humidity of this air coming down from the north is in the single digits, like 4%, right? 2%. Whereas the warm, moist air coming up from the Gulf of Mexico the humidity might be 40%. It's really different down there. People love it in the southeast of Florida, right? They love it down there. It's warm, it's moist. You get rain, you get tornadoes, but it's not cold. But when this warm, moist air travels north and hits this cold Arctic air mass, you get what we're experiencing right now, which is a real shit show. They're having a real shit show right now in this area across here. That's what's happening. All of this, everything I just described in the last 2 minutes is global heating. All of it. 100% of it is caused by global heating. And if that's unintuitive and that can't be right and you just made that up and no one knows who Jennifer Francis is and can't trust the scientists and the satellites it's all a hoax and the world isn't a sphere or a globe, the world is flat and none of this makes any sense and that's where you're at, well then fine. And maybe you're not because you're on my channel and you're listening to me and you didn't bail out. But maybe you have a friend who is, or maybe you have an uncle who is, and they're like, none of this is real. This is all normal. Well, it's not. And the climate scientists know it's not. And the meteorologists probably know it's not too. They're just not going to tell you. They're the ones with the platform. Max puts out a weather report every single day, even though he does extreme weather. It's right there on his channel. Max Velocity, Severe Weather Center. Even though what he does is severe weather. He does a major 12-hour broadcast once or twice a week. I don't think he signed up for that. But he has a big channel. He has 1 million subscribers, almost. And, he'll have 25,000 people watching his live stream, and he's probably making really great money. Good for him. He's a young guy. I hope he does well. But he's supposed to be doing severe weather. And there's just no shortage of severe weather. And he's on here all the time. And he does a weather channel update. Generally, how long is this one? I don't even know. Oh, there it is. 12 minutes. This is a 12-minute weather update. And then he'll do a 12-hour severe weather live stream. And that's how it is. Every single day. He does a severe weather update of 12 minutes or so. And twice a week, he does a severe weather live stream. And if you're noticing that that's the trend, you'd be right. And if that worries you, you are correct to be worried. This worries everybody. And the climate scientists are absolutely losing their minds. They are in deep depression over all of this. We don't know what to do. We don't know who to talk to. We don't know. There's no president that's interested. There's no weather channel that's interested. No one's doing documentaries about this. This is essentially the end of the human world. If this continues the way it is, it's just essentially the end. All these states across the middle of this event have declared a states of emergency. All the way through here. These are all states of emergencies. And how many billions of dollars is that going to cost? And how much lost productivity is there going to be? And how many homes are going to have repairs? And how many people are just going to have to be repaired? And their equipment and their trucks and their roofs that are falling in because of the snow and, sliding into the ditch and tearing up their car and tearing up their truck and, losing their cargo. And how many billions of dollars is this one event going to be? And after a while, a billion here, a billion there, pretty soon you're talking real money. So if you just want to talk about the money, talk about the money. Max, who just does severe weather, does 2 of these a week. And if every one of them costs $1 billion, which is not out of the question, these are huge areas of disaster. If every one of these costs $1 billion, net of net, then, that's $2 billion a week. That's over $100 billion a year in weather damage alone. And that's just if each event is $1 billion. There are hurricanes that come ashore in places like Florida that are probably $20, $30 billion events. Or tornado going through the wrong part of Kentucky can cost $1 billion. Just one tornado all by itself. A tornado outbreak could be more than that. Real money. And these places, especially the ones I have outlined in red, but also extending down to here, these places, and I'll include Florida because of the hurricanes, these places are becoming uninhabitable. You can't get insurance. And if you get insurance, then your insurance premium goes up after the disaster and you can't afford it, or it takes all your money to operate with insurance. And then you have to leave. And where are you going to go? You're going to go north? You're going to go to New England? Do those people want you up there? You're going to go to California? You spent your entire life brickbatting California as being a bunch of liberal retards. How well are you going to fit in over there? They have to leave. These people have to leave. It's just one disaster after another. And you'll notice that's the case. If you keep watching, watch these areas and ask yourself if they're habitable or not. Western North Carolina got completely broken off in Hurricane Helene. And those people are living in tents right now. And it's 10 degrees below zero, 40 degrees below freezing. And they're living in tents. And how is that supposed to work out? I don't think that works out. So that's enough for me. I got other things to do. I just wanted to say that while it's fresh in people's minds. I think it's important that I do that once in a while, if only to put proper context in this, because the weather people aren't doing it. Sometimes they'll catch themselves out and they'll like, wait, what is that? But they won't talk about it. And they won't talk about it more than once, because if they ever do, then the people that they're supposedly trying to serve will come unwound. They just lose their shit. Oh, now you're talking politics. Just keep to the weather. So they do. It's called audience capture. Your audience tells you what you can tell them. Well, that's dumb. Really? This guy's supposed to be the expert. He's gone to college to learn the weather, and you're going to tell him what to tell you? Really? That's how we're going to do this? How stupid and moronic is that? Well, cognitive dissonance. Can't have the truth. I can't have it out that I'm in a bad place and I don't understand what's happening to me. I can't have it get out that I was wrong. And, they're just going to go down the drain. Some of them, the ones with money, will get out, and the rest of them will just go down the drain. They won't survive. At some point, this is just going to become uninhabitable. And if it's not the current ice storms freezing everything up and putting the trucks in the ditches, well, then it's going to be the hurricanes and the tornadoes. And, I sound like a doomer. No, I'm not. I'm talking about the climate. These people are done. They're just done. And they don't know that. I mean, they know that. They don't want to hear it. And I understand that. They don't want to hear it. Fine. Fine with me. I mean, good luck. So that's what I got. I got to go outside and work. My wife is going to yell at me for being in here doing this, but I felt it had to be done. Again, go watch her stream from December 31st, and she had some good things to say. Definitely give her a thumbs up. And if you want more of this from me or her, be sure to subscribe to the channel. And, I don't come back here a whole lot, but when there's something that catches my fancy, well, I'll come back on here and I'll talk. I guess if you got topics you would like for me to cover as a climate scientist, put them in the comments and I'll think about it. I don't generally take requests, but I'll think about it. I mean, do you really want to know? Do you really? Seriously? You want to know? I'm also finishing my book. It was 100 Days, and it's kind of about what happens when modernity fails because of the lack of fossil fuels. So that should be coming out soon. I don't know what I'm going to do with it. I might put it on Amazon Publishing. I might read it and make it an audiobook here on the channel. I don't know. I'll think about it. But, it's been fun. I have enjoyed writing it. And, yeah. Unfortunately, my fiction is rapidly becoming a documentary. So hopefully I can get it out as fiction before the events of the day catch up to me, and it's just a documentary. So we'll see.